So today we will be solving some more problems on Kirchoff's laws. So let us go to the first problem. So we have to find out all the branch currents. So determine all the branch currents. So how do we do this? Now let me use the branch current method here. So as I've told you, you can proceed with any of the method, mesh method or your branch current method. I will be going through the branch current method. Okay, so let me first, what I'll do is I'll mention these loops. Okay, so this is A, B, C and D. Okay, so next what I'll do is I'll mark the directions of the current. I'll take the directions of the current. So what I'll do is I'll start from this. Now, since in your calculators you have highest order of variables that you, or the highest order of unknowns that you can find using unknown calculator is 3. So whenever I solve any circuits, what I'll do is I will try to keep at the maximum 3 variables itself. Okay, so what I'll do is I'll consider that my main current is flowing from this. Okay, so this is given as 10 volt. So I'll consider that the main current is flowing from this. So at this point what happens is my current will divide, right? So what I'll do is I'll take the first current here as I1 and the second current here I will take as I2. It is better you start from the supply, that as you already know your current will flow from the positive terminal. So from the positive I will start here. So you know from the positive terminal means current will flow like this, right? So it will flow like this. So at this point what happens is it will divide into the 2 branch. One current will go in this first branch. So let me take that current as I1. The current that is going in the second branch I will take it as I2. Now let me consider this first branch. Now at this point, at this junction, what happens is again the current will divide, correct? So current will flow in this and current will flow in this. So what I'll do is I'll take the current flowing in this branch as current I3. Similarly, I'll take the current flowing in this last branch, that is in AC, I will take it as I1 minus I3. Now let me take at this node. Now at this node if you see I3 is flowing inside, I2 is flowing inside. That means the next branch will be I2 plus I3. Next, at this node let me take, so if you see at this node, in this branch I1 minus I3 is flowing, in this branch I2 plus I3 is flowing. So what will be this? So in this what happens is current will flow this side. So this one will be I2 plus I3, that is which is flowing inside the node here, plus this current is also flowing inside, so it will be I1 minus I3. So this and this cancels, so you will be left with I2 plus I1 current which is flowing in BC branch. So you are left with I2 plus I1 current. So this is the final branch, right? Now that means this current I2 plus I1 is flowing through this. So you can see it through this supply also, you can say I2 plus I1 is only flowing, correct? So now at this node if you see I2 plus I1, you can see here I2 is flowing this side, I1 is flowing this side. So you can see here you had started with I1 and I1 plus I2 currents. You ended up with I1 plus I2 current at the final branch. So this is a way of checking whether the currents that you have taken in the circuit is proper or not. That is, if you are starting with I1 plus I2 current, end up in the last branch with I1 plus I2 current. If you are starting with I1 current, end up in the next last branch with I1 current. So that is a method to check whether the direction or whether the current that you have taken is proper or not. So I have already mentioned the currents. Now what I'll do is I will mention the signs. So my current is flowing upwards like this, that means this will be plus and this minus. So here again current is flowing like this, so this is plus and this is minus. Here downwards, so this will be plus and this minus. Here it is flowing like this, so plus and minus like this, so plus and minus. So this is flowing like this, so this is plus and minus. So now let me write the equations. So first let me write the equation for your first loop, that is I'll apply the equation for B A D B A loop. So let me start now. Let me take in this one. Now again, while writing the equations, you have to go in any one direction. Better to follow any one direction. Either you can go in clockwise or in anti-clockwise, doesn't matter. Okay, so let me write the equations in the clockwise manner. So I'll start from one of the resistor. Okay, so let me start from the, say, this 1 ohm resistor. So while I'm going clockwise like this, what happens is I'm going to enter positive, so it will be minus 1 into current is I1. After 1, the next resistor here is 2. I'm again entering at positive, so it will be minus 2. Current in 2 ohm resistor is I3. So after the 2 ohm resistor, again I'll be going through 4 ohm. 4 ohm, what happens at 4 ohm? I'm entering minus, so it will be plus 4 into current through 4 ohm is I2 equal to 0. So I'll arrange it like this. So I1 plus 4I2 minus 2I3 equal to 0. So this is my first equation. Next I'll write the equation for the next loop, that is A, C, D, A loop. Correct? Yes. Next loop I'm taking is AC, D, A loop. So again what I'll do is I'll follow in any one direction. Let me take the clockwise direction itself. So let me start from any one of the resistor. I'll start from 2 ohm. So while I'm going clockwise like this again, I'm entering the minus sign, right? So while you are writing, it will be plus 2 into current in the 2 ohm resistor is I3. Next, when I'm going like this again, I'll be entering the positive of 1.5, so I have to write it as minus 1.5. Current through 1.5 is, you can see here, current through 1.5 is I1 minus I3. So I1 minus I3. So after 1.5, while I'm going like this, so the next resistor is 6 ohm. Again, I'll be entering the minus of the 6 ohm. So it will be plus 6 into current in 6 ohm is I2 plus I3 equal to 0. So what will it be? 2I3 minus 1.5 I1 plus 1.5 I3 plus 6 I2 plus 6 I3 equal to 0. So let me arrange in terms of I1, I2, I3. So it will be minus 1.5 I1, next plus 6 I2, next 9.5 I3 equal to 0. So this one will be the second equation. Next I will put the KVL in the loop B, D, C, B loop. So again I'll start from one point. Let me go again in the clockwise direction itself like this. So I'll start from one point. Say let me start from 4 ohm resistor. So while you're going like this, so you will be entering the positive. So positive means you have to write it as minus 4. Current in that is I2. Then again, so I'm going like this. So while I'm going like this, I'm entering the positive. So it will be minus 6 into current is I2 plus I3. Next, from here, the next quantity is this one. I'll be entering positive again. So minus 2 into current in that is I2 plus I1 Next, from here, after this 2 ohm, then you have a supply. So again you will be entering the minus of that supply. So it will be plus 10 equal to 0. So this one will be, so you can also write it as minus I1 minus 6I2 minus 3I3 equal to minus 5. So this is your third equation. Now, once you substitute in your scientific calculator. So in your scientific calculator for a for your 3 variable equation, you have a equation in terms of ANX plus BNY plus CNZ equal to DN. You will find an equation in this form in your scientific calculator. So from the first equation, A is minus 1, B is 4, C is minus 2, D is 0. From the second equation, A is minus 1.5, B is 6, from C is 9.5 and D is 0. From the third equation, A is minus 1, B is minus 6, C is minus 3 and D is minus 5. So I am going to substitute this in the scientific calculator. So while I substitute this in the scientific calculator, I will get the answers for I1, I2 and I3. So I1 answer I will get as 2 amps. So I2 I will get it as 0.5 amps. And I3 I will get it as 0 amps. So now in your this one problem, if you see, they have given you determine all the branch currents. That means I have to mention the currents in each of the branch. Now whatever I have got is I1, I2 and I3. That means I have got the current in AB branch, I have got the current in BD branch and I have got the current in AD branch. What about the other branches? So whenever they ask you for finding out the branch currents in all the branches, what you have to do is you have to separately write. So current through branch AB. So branch AB is I1. So I1 equal to 2 amps. Next, current through branch BD. So current through branch BD is I2, that is which is equal to 0.5 amps. Next, current through branch AD, that is I3, which is equal to 0 amps. Next, current through branch AC. Current through branch AC is I1 minus I3. So current through branch AC is I1 minus I3. So I1 minus I3, that is 2 minus 0, that will be equal to 2 amps. Next, current through branch DC. So current through branch DC, if you see, that is I2 plus I3. So I2 plus I3. So 0.5 plus 0, which is equal to 0.5 amps. Next, the remaining branch, that is current through BC. So current through BC is I2 plus I1. So 0.5 plus 2, that will be 2.5 amps. So this is how you are going to find out the answer. You instead of getting your 2 amps, 0.5 and 0 amps, even if you get the answer as minus 2, minus 0.5 amps and 0 amps, that doesn't matter. We are only concerned about your constants. This sign doesn't matter because this sign will just tell you that the direction of the current that you have taken is actually opposite to the actual direction of the current in the circuit. So this circuit, these signs doesn't matter in the final answer. The only thing that we are that is mattering is the constants 2.5. constants should come the same. Directions will not matter. You can just write in the final answer that if there is a negative sign, you can just write that the current and the direction of the current taken is actually opposite to the actual direction of the current. You can write it like that if you are getting a negative answer. So this is your first problem. So let me go to the next problem. So I have a circuit like this. So this is my circuit. They have asked you to find the current in all branches of the network. So you have to find the current in all branches of the network. So let us see how to do this. So first let me mark this nodes. So I'm going to mark this A, B, C, D, E and F. Okay, so I have marked these nodes. Next, I will assume that current I is flowing in this branch. Okay, so let me start from this branch. I am assuming that the current I is flowing in this branch. Now at this node, what is happening? You can see current I is flowing inside, 60 amps is going outside. That means what will be this current flowing in BC branch? It will be I minus 60. Next, at this node if you see, I minus 60 is flowing inside, 60 is also flowing this side, inside. So what will be this branch DC? It will be I minus 60 plus 60. So this and this cancels, that means you will be left with I amps. Next, here at this point, you can see here current I is flowing inside, 120 is flowing outside. That means this current will be I minus 120. Now again at this point at E node E, what happens is I minus 120 is flowing inside, 70 is also flowing inside. That means at this branch it will be I minus 120 plus 70. So which will be giving you I minus 50 amps. Next, at this node, F node, you can see 30 amps is going outside, I minus 50 is going inside. So this branch will be I minus 50 minus 30, which will give you I minus 80 amps. So at this node, if you see, what is happening is I is flowing this side. So you can see here at this node, I minus 80 is flowing inside, 80 is flowing inside. So this branch is what? I minus 80 plus 80. So you will be left with I, right? So you had started with current I, you ended up with current I in this branch, correct? So that means the way that you have taken the currents is proper. So this is the way you analyze whether you have taken proper currents or not. So what you are going to do is you will start with one current, say I current. You will go across and come back at that same branch, and if you are ending up with the same current in that branch, then the current that you have taken or the directions of current that you have taken is proper. So now I have taken the directions of the current. Now what I'll do is I'll mark the signs. So my current here is flowing downwards, so this one will be plus and minus. So here it is again flowing downside, so plus and minus. So plus, minus. So this is also plus and minus. Plus, minus, plus, minus. Okay. So now what I'll do is I'll write the KVL equation. So I'll go in the clockwise direction. Okay. So let me apply KVL to loop A, B, C, D, E, F, A. So let me start from this first I equation. So now when you are going like this in the circular manner, you will be entering the positive, so it will be minus I. The resistor is 0.02 ohms. The next is again minus 0.01 is the resistor, I minus 60 is the current. Next, from here again you will be entering like this. Again it will be minus 0.03 is the resistor, current is I. Next, from here again I will go like this. Again I am entering positive, so it will be minus 0.01 is the resistor and current is I minus 120. Next, from here I am going like this again. So again what happens is 0.01 is the resistor. So 0.01. So current is I minus 50. So again from here I will go like this. Again I am entering positive, so it will be minus. Resistor is 0.02. Current in the branch is I minus 80. So until here, so all this is done, so equal to 0. So now can you find out the answer for current I? So you have minus 0.02 I, next you have minus 0.01 I, next plus, minus into minus plus, 60 into 0.01, so that one will give you 0.6. So 0.01 into 60 will give you 0.6. So plus 0.6 minus 0.03 I minus 0.01 into I, minus into minus, that is plus. So plus, so 0.01 into 120. So that one will give you 1.2. So plus 1.2. Minus 0.01 into I, again minus into minus, this is plus, 50 into 0.01, so that one will give you 0.5. So 0.5 minus 0.02 into I, again minus into minus plus, so 0.02 into 80, that one will give you 1.6 equal to 0. So now find out what is I. So you will get minus 0.1 I plus 3.9 equal to 0. So you can say 3.9 equal to 0.1 I. So I will be equal to 3.9 divided by 0.1, which one will give you 39 amps. So this is the main current. Now you have to find out the current in all the branches. So current in AB branch, so that is I, which is equal to 39 amps. Next, current in BC branch, that is I minus 60. So I minus 60 means, so you will get 39 minus 60, that one will be equal to minus 21 amps. So you can say, you can actually write here that, so BC, if you see, you have taken the direction of the current as B into C, but actual direction of current is from C to B. So you can say actual direction of current is C to B. Okay. Next, the next this one is CD. So current is I, that is 39 amps. Again DE, that is I minus 120, 39 minus 120. So that one will give you minus 81 amps. So again, because it is minus, that means actual direction of its current is from E to D, correct? Next you have EF. So from current EF, it will be I minus 50. So that will give you minus 11 amps. Next, from F to A, current is I minus 80. So I minus 80, that is 39 minus 80 will give you minus 41 amps. sorry, 39 minus 80 will give you minus 41 amps. Okay, so this is the branch currents. So again, since it is minus, you can say the current and the actual direction of current taken is opposite. So this is your another type of problem. So let us go to the third problem now. So you have to find first question is current supplied by 100-volt source, and the second question, that is you have to find out voltage across 6 ohm resistor. So let's see how to solve this. So this is the circuit given. So first what I'll do is I'll mark the currents. So this can be solved directly using your Ohm's law and also by solving for series and parallel resistances. Okay. So what I'll do is first I'll mark the currents. So let me take the main current that is flowing is current I. At this point the current is going to divide. So I'll take this current as I1. So this current is I2. So since I'm going to solve this by using your series parallel resistances equation, that is by finding out equivalent resistances and then by using Ohm's law, I will take different variables here. So since I'm not using Kirchoff's laws, I need not take only 3 variables. That constraint is there only for Kirchoff's law, just because I have to apply it in the scientific calculator and get the answers, or else you can take, no problem. So I1, now at this point again current is going to divide, so I3 and I4. Now again I3 current flows like this. Now at this point again it will divide. So I've taken I1, I2, I3, I4. So I'll take this current in this. So this current I'll take it as I5 and this I'll take it as I6. Okay. Now I have to find out the currents. Now from the first question they have asked you current supplied by 100 volt source. So current supplied by 100 volt source is I. So I have to first find out what is I. Okay. Then you have to find out what is the voltage across this 6 ohm resistor. Next. First I'll solve this. Now you can see here 6 ohm and 3 ohm resistor are in parallel. So that means Rp1 equal to 6 into 3 divided by 6 plus 3. So this one will give you 2 ohms. So that means my circuit will look like this. 5, 10. 5 ohms, 10 ohms, 5 ohms. So here you have 3 ohms. Then the 6 into 3 and 6 plus 3. So this one will give you 2 ohms. So this equivalent resistance is 2 ohms. Now again if you see 5, 3 and 2 are in series. So you can say RS1 is equal to 5 plus 3 plus 2. So this one will give you 10 ohms. So again my circuit will look like this. 5, 10, 5, 10. So this 532 can be written as 10 ohm. So again if you see this and this is in parallel, so Rp2 I'll take, so it will be 10 into 10 divided by 10 plus 10. So that one will give you 5 ohms. So so I can also write this as 5 again. So again, if you see 5 plus 5, this is in series. So I can write it as RS2 equal to 5 plus 5, which is equal to 10 ohms. So next, let me write it in the next this one. So this can be written as, this circuit can be written as, so here only let me write. So it will look like this: 5, 10, and this 10 ohm resistor. So 100 volts. Again, if you see 10 ohms and 10 ohm is in parallel, so you know 10 ohm 10 ohm parallel, here we have already calculated, that only I can take. So say Rp3 is equal to 10 ohm and 10 ohm is in parallel, so 10 plus 10 will do, that one will give you 5 ohms. So now my circuit will look like this. This is 5 ohm and this is 5 ohm. And this is 100 volts. So again you have 5 ohm and 5 ohm in series. So solve that. So 5 plus 5, which is equal to 10 ohms. So your circuit, final circuit will look like this. This is 100 volt. So you have a resistor 10 ohms. Okay. So this is your final circuit. So main current flowing through 100 volt is nothing but main current, that is I. So I'll take the main current flowing from 100 volt is I. So from this circuit, what I'll do is I'll apply Ohm's law. V is equal to I into R. You know main supply voltage is 100 volt. Main current I is, I have taken the variable as I, then resistor is 10. So what will be I? 100 by 10. So this one will give you 10 amps. Okay. Next, I want to find out the, so I want to find out next what is I1 and I2. So what I'll do is, I will go back to this circuit. Okay, I'll consider this circuit. Now how does this circuit look like? So let me draw this again if you want. So why I'm going back is, I have already found out like this resistors. I have simplified in using series resistances, parallel resistances, and I have ended up until here. So I have got the equivalent resistance and I found out what is the main current. But now I want to find out this currents I1 and I2. How can I find out this? So in order to do that, what I'll go do is, I'll go to the previous circuit from this. So where my currents are divided, that is, this is current I, this is I2, and this is I1, right? So I have to find out what is I2 and I1. So this circuit I'll go. Now, how can you again write this circuit in a different manner? So if you have like this, so you had here 5, 10 and 10. Now how does this circuit look like? So does it look like a parallel circuit, right? It looks like a parallel circuit, right? So for the parallel circuit, this is parallel circuit, right? 10 amps, you have 5 ohms here, and then you have a voltage source here. So how does this look like? So you can see this is a parallel circuit. Now for a parallel circuit, what happens? Only current changes, voltage remains the same. That means for this 10 ohm resistor, the voltage is 100 volt. For this also 10 ohm resistor, the voltage is 100 volt, right? 100 volts is the voltage for both of the resistors. Both the resistors are also having the same resistance. So that means this current will divide into half. So current that is flowing from here is nothing but 10 amps. So 10 amps will divide into half. So that one will be I1 equal to 5 amps and I2 equal to 5 amps. Correct? I have to now find out what is I3 and I4. I have found out that is 10 amps. I1 I have found out 5 amps and I2 5 amps. Okay. So now next I have to find out what is I3 and I4. So for I3 and I4. So which one is this? So this circuit, right? So this one was I2, I1, this is I4 and I3. So this circuit. Now in this circuit I have to find out again. So according to this again, you can see the main current that is flowing into this part is 5 amps, whereas your currents that is flowing in this 10 ohm resistor is I3, this is another one. So again I have to you can see here voltage across this is 100 volts, that is this is a parallel circuit. So voltage across the parallel circuit is always the same. So what happens is the main current will again divide into half, correct? So what happens is you can write I3 equal to I4, half of 5 is 2.5, directly you can write, correct? Next, again if you go here, so I3 equal to 2.5 amps, this is equal to 2.5 amps. So 2.5 amps is flowing here. Now in this, here what happens? So you have 2.5 amps flowing in, so you have 3 ohms, and here you have 6 ohms flowing. So this is I6 and this is I5. So how can you solve this? So now what you can do is you can use your current divider rule, if you remember. So according to the current divider rule is how I1 is equal to main current into the resistor in the another branch divided by total resistances, correct? So what I'm doing is I'm going to use the current divider rule here. So I5 is equal to main current, that is 2.5, into the resistor in the another branch, that is into 3 divided by 3 plus 6. So that one will give you 0.833. Similarly, I will apply my current divider rule to the another branch. So say I6 is equal to main current 2.5 into the resistor in the another branch, that is 6, divided by 3 plus 6. Okay, so 1.6. So now, what is your second question? They have asked you voltage across 6 ohm resistor. I want to find out what is voltage across 6 ohm resistor. I can easily find out now using Ohm's law. V is equal to I into R. Because I know the current flowing in the 6 ohm resistor. Now current flowing in the 6 ohm resistor is 0.833. What is the resistor? Resistor is 6 ohm. So what will be 0.833 into 6? This answer will give you the voltage across the 6 ohm resistor. 4.998.